Hi, AB Calculus class. My son Lewis is going to be helping me film this video. It's 2005, question number 3. No. Explain to them. Come over here so they can see you. How are you going to be helping? Look it up a little higher.
I'm going to be shooting Dad.
How are you going to shoot me? With a?
Nerf gun.
Nerf gun. That's great. And can you look at the video camera, tell them why today is special.
Because it's my dad's birthday.
And how old did I turn for my birthday?
40.
40 years old. Is that young or old?
Old.
Really old or just a little old? A little old. Okay. All right. So he might shoot me with a dart gun, and if you have any other ideas for how Lewis can be involved in videos, please let me know. But at least one a day, he's going to be helping me out. So today he's going to be helping me by shooting me with dart guns, or Nerf guns, whatever. And other days, who knows? So we'll see. All right. So we're going to do question 3. And we're going to do part A. Now, part A is the same part A that I told you was going to happen over and over and over again. We have a chart of t of x, and for part A, they ask you to estimate t prime 7. Okay. Now, they don't want the real answer, they want you to estimate it. Lewis is just staring at me, mesmerized by math. I think he's got, shot my hand. Okay, all right. Anyways, so here is what you need to know. If you have some graph and you want to find the real slope, t prime 7 would be the actual slope of the tangent line. But what we want to use is we want to use 2 points to estimate the slope. Remember, t prime x would give me the slope of the tangent line, so t prime 7 would be the actual slope or the actual rate of change at 7. So we are estimating slope. Instead of using the derivative to get the exact slope at one point, we're going to use 2 points that are near 7. So we're going to use those 2 points. Remember, when you're finding slope, these are considered the x's and the y's. Subtract the y's on top and the x's on the bottom. Now you could have done it in the other order. You could have done this minus this and this minus this. But anyways, you'll see here you get 7 over -7 over -2, or you could just call it -7 over 2 if you wanted to. So -7 over 2, and then they want units for the final points. Units are really easy. Look at what you subtract on top. Just put down the units of what that is. The units of what you subtracted on top were degrees Celsius, and then on the bottom you subtracted these numbers, which were distance. So it's degrees Celsius per distance. Now think about it this way. If you've ever cooked something, you have a hot pot. You have a hot pot with a handle coming out, and the handle is cold when you begin cooking. But as you begin cooking, the heat travels down the handle and eventually increases the temperature of the handle. So this is basically saying the closer you are to the heat source, you get the full temperature, but the further away you get, the temperature is less. So it's at some specific point in time where things are at. Okay? Alright, so let's go ahead and look at part B. It says, you changed your angle. Dude, you're going to be out of bullets soon. It says, write an integral expression in terms of t for the average temperature of the wire. Now, some people are going to skip that first sentence and go directly to the next part, which says, write a trapezoidal sum. Oh, I'm so happy I know how to write trapezoids. No, okay. First part. Write an integral expression in terms of Tx for the average temperature. The word average in calculus is never used in vain. So, that was a close shot. So, the average temperature for part B, average temperature 1 over B minus A, integral from A to B, and then T of x dx. Now, your A and your B here, it says the average temperature of the wire. So the wire is 8 centimeters long. Lewis. So 8 minus 0 from 0 to 8. Now, obviously 8 minus 0 is just 1/8. So this is the first part. You get points for writing down this. And then the second part says, okay, now go ahead and use the trapezoidal sum. So the trapezoidal sum, here's what you have to remember. If you have some curve, whether you're using left-hand rectangles or right-hand rectangles or trapezoids, they're used to estimate the area. So the 1/8 goes here, and then the trapezoidal goes here. All right. So a trapezoid formula is 1/2 height, base 1 plus base 2. So for each section, we're going to do this. So it's 1/2 times height, base 1 plus base 2, 1/2 times height, base 1 plus base 2, 1/2 times height, base 1 plus base 2, and we might need one more, I think. 1/2 times height, base 1 plus base 2. Now notice it's all in brackets, or it could be parentheses, and then 1/8 times all that. All right, so the height of the first one is how far are 0 and 1 apart? That's a 1, and then you use the... You got me! Use this for your two heights. So here we have 193. So here the distance between them is 4, and again we use these two, 93 and 70. And then here again the height is 1, and then we use these two for the base 1 and base 2, 70 and 62. And finally the height of the last one is 2, and we're using these two, 62. Oh! You keep, where are you now? Oh, he's hiding in the room now. Oh, there you are. All right, 62 and 55. So, folks, this long answer is your answer, okay? Even though this is a calculator question, there's no reason to type it in your calculator. If you type in your calculator, you'll get 75.6875. But this is how I choose to write 75.6875. All right, let's go to part C. Part C looks like a crazy question. So you're going to get to part C, you're going to look at it, and... Did you resupply? Did you stock up on bullets again?
No. Yeah, I mean, yes.
Oh, you're sneaky. I didn't even see you get them. Okay, so for part C here, it's one of those questions that looks like you're going to have no clue what you're doing, and that it's actually not going to be that bad. All right, so the question is to find 0 to 8 t prime x dx. And again, you're looking at this and you're like, the area underneath t prime x, I don't even have t prime x, what do I do? In calculus, if you don't know what to do, think about this, it's follow the rules. I need the area underneath t prime x, I don't have t prime x, what in the world do I do? Well, remember, the area underneath the curve gives the net change in the antiderivative. So let's follow the rules. The rules say take the antiderivative of t prime x. The antiderivative of t prime x is simply t of x. And then after you've done this, you plug in the top and the bottom and subtract. Plug in the top, plug in the bottom, subtract. T of 8 is just the number on the chart, 55. T of 0 is just the number on the chart, 100. Whoa. And if you subtract them, you get the answer of negative 45. Now, they say explain the meaning of this answer in terms of the temperature of the wire. Okay. So, what we found here was the net change. Okay, the net change in the antiderivative. The antiderivative is t of x in temperature. Okay? So, what we found was in degrees Celsius. So this would be in degrees Celsius. Notice we're just subtracting two temperatures. That's a temperature, that's a temperature. You're subtracting temperatures, you get a temperature. So this would be the change in temperature, or this would basically say that the temperature decreased by 45 degrees. So the temperature decreased, notice I'm using the word decreased to talk about that, by 45 degrees Celsius from
Only have 3 bullets.
the handle, is it? Basically from here to here. When the distance from
I have 2 more bullets.
basically the beginning to the end of the wire. Let's see how they word it in here. From the heated end of the wire till the other end of the wire. Okay, that's part C. And let's go to part D. Are the data in the table consistent with the assertion that the second... Oh, gosh, not the neck, dude.
didn't mean to aim at the end.
Alright, remember, nothing up here.
I know.
I don't have on my eyewear. That was way too close. Folks, we almost had a hospital trip here. Alright, so part D says, hey, is this true? Now, folks, if they ask you if something is always true, if you can use the mean value theorem or the intermediate value theorem, then maybe, okay? But a lot of times when they ask is something true, what you can do is just find one way to prove it's false. If it's false for one thing, it's false. So here is what I'm going to say. If the second derivative was greater than 0, that would mean t of x is concave up. Oops, not concave up like that though. Can you see how the numbers are getting smaller? It should be concave up and looking like this. Okay? Now, if this is true, if the second derivative is greater than 0, the slopes are actually always getting bigger. Now, what do I mean by getting bigger here? Because you might be like, Mr. Pike, well, this is a negative slope, and then the slopes. Let's just look at a whole thing that's concave up. While it's concave up, a big negative slope, the slopes become 0. Now the slopes become positive and steeper. If something is concave up, the slopes are the slopes are always increasing. Okay? Or another way is if I had a sign chart of t double prime x and it was always positive, this plus sign would go 2 before and say the temperature is always concave up. But if you just go 1 before it, a plus or a minus always tells you the one before it if it's increasing or decreasing. So this would say it's increasing for the one that came before it, t prime x. So this second derivative being positive told me t prime x should always be increasing. And that's what we're going to try to disprove. And we're going to do it in one different way. And I looked online just to see how they did it. And they found the slope that went right through the armhole there. They just found the slope here. Let's see, from 1 to 5, and then from 5 to 6. 1 to 5 and 5 to 6. And they just looked at the slope both times. Now, remember how we estimated the slope before. So, t prime x is about on the interval from 5 to 6. Okay? And if we just find this hey, Lewis, can we stop just for just a little bit because I can't focus? Because it's a hard problem. Just give me 1 minute. Let's first go from 1 to 5. Okay? If I find the slopes from 1 to 5, just like we did in part A, I subtract these on top, these on the bottom, 70 minus 93, and 5 minus 1, and I subtract, and I have a calculator, so I'm going to type it in the calculator, and I get negative 5.75, and now I'm going to estimate the slope on the interval from 5 to 6. And from 5 to 6, I'm going to subtract the y's on top, the x's on the bottom, and I get a slope of, okay, you can use it again. We're almost done. You can pull out your gun and start.
I know!
All right, anyways, so here all I'm trying to show you for the very end of the problem is look at the slopes. The slope was at -5, and now the slope is at -8. Notice the slope went down. That meant the slope, again, t prime x went down, it was decreasing. And what they want us to prove? That the second derivative is always greater than 0, meaning t prime x would always be increasing. It's not a great question, but you can find these two different slopes. The slopes of t of x are t prime x. You can see the slopes were actually getting smaller from a negative to even a bigger negative, so t prime x was decreasing instead of decreasing. Therefore, the answer is nope. It cannot be true. All right, Lewis, will you say goodbye to everybody live?
Bye.
Bye. We'll see you tomorrow. Please give me some ideas, maybe post on the stream, how Lewis could help me in ways that it might not hurt as much. I'm just kidding. All right, see you guys. Bye.